Everybody. This is the first robotics manipulator presentation. I've done this a couple of times. This year is going to be a little different because 2020, everything's different. So, all right, little bit, let's see. Okay, here we go. A little bit, did I skip anything there? Yes. Oh yeah, this one. I'll be giving part 2 and part 3 of this talk on November 14th and December 5th, respectively. I'm the head coach of Team 3023 Stark Industries. We lean pretty heavily into Ironman. We love that. And if you are curious, we're completely infringing upon the copyright, but we have contacted Marvel and asked them to sponsor our team. They didn't reply. So until we get a cease and desist letter, you know, we looked into the law on that one. My first year coaching was 2010 Breakaway. I will still always have fond memories of Breakaway. It was a fun year. This is one of our images that we have out there because honestly, we love Iron Man. His only superpower is he knows robotics. Part 2 and part 3, the ones that'll be in November and December. Part 2 is going to talk about secondary tasks, arms and elevators. That's going to focus more on game elements, like the actual field elements. Part 3 is kind of everything that I couldn't fit into part 1 and part 2. So first question. Feel free to answer this in the chat. What is the official definition for manipulators? I just realized I can't see the chat. Okay. All right. So the question, let me see. So the official definition is this: a device that moves the game piece from where it is to where it needs to be. That's, you know, not the official one. What do teams actually use as the definition, though? It's the thingy that's not the drivetrain. That's what the manipulator is. That's what all the manipulators are. So the first and most important question, it's actually not true. This is tied for the most important question that you need to answer is this: manipulate what? And the question for this we're going to talk about game pieces. They come in all shapes and sizes. And this is my little thing about 2020. Let's be honest, 2020 is a dumpster fire. This is just horrible. But our team motto, our official team motto, is to make it work. And because of that, we've been trying to figure out, so what's the best thing you could do with a dumpster fire? How do you make the best of the situation? Our answer is s'mores. So this is the joke that we're saying all year. We're going to try to make s'mores over the dumpster fire because we're going to try to make the best of the situation. And Dean said this beautifully. He framed this: the state of the world and all of its problems is a time of immense opportunity. And that is breathtakingly optimistic. I love that. And I was really honestly inspired. And that's why there's an I for inspiration in the word first. So this year, the challenge is different, but honestly, every year the challenge is different. They throw something different. And this year is just like really different. So as I'm going through this, talking about all the game pieces, I want you to think about how those game pieces from the past have been used in previous challenges and how you can incorporate that and use that in your thinking process, your decision process for the game that you're designing for this year's challenge. Also, this is an amazing year to prototype. I'm going to show you a bunch of different designs for game piece manipulators. And let's be honest, a lot of us, some kid comes up with this brilliant idea that's like really complicated and hard and scary. And we say no because, you know, you don't have the time, you don't have the experience, you've never done that before, you can't get the parts in time. Well, this year is perfect for that. You can prototype and, you know, there's some kid on the team who's asked 3 times in a row to make this very specific type of, you know, launcher or climber or some sort of mechanism. And you've always said like, well, we can't get the part, blah, 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 blah. This is the year for that. The other thing is training. We're going to be trying to train like never before. So all that said, that's kind of the context that I want you guys to frame this presentation in and how it applies to this year's challenge. There's another coach that said he sends kids to this presentation just for the following slides because it gives you, this is every game that FIRST has ever had from the first one in 1992. That was maze craze. They had tennis balls and they were in corn. It was weird. 93 was a lot more like what you would think of. 94, soccer ball. 95, we had the large exercise ball. 96, 96 had 2 game pieces similar to 93. 93, I forgot to say, there was a water-filled ball. So arguably we did have a water challenge technically for those of you who are on the water challenge craze. Also, I guarantee there's going to be a lot of teams who design a water challenge this year, but I'd like to see how they make that work. So 97, inflatable tubes. 98, we had the exercise ball. 99, double trouble with the floppies. We'll talk about that a little bit later because, wow, yeah, there are people who were around for that have, Andy Baker of Andy Mark has horror stories about the floppies. 2020, the actual name of the, or sorry, 2000, the 2000 competition was actually named Cooperation. 2001, Diabolical Dynamic, Zone. So we have this one, another soccer ball popped up, Stack Attack. For those of you who are around for Recycle Rush in 2015, that was not the first time that we had totes. So then we got 2004, Frenzy, Raising the Bar. 2005, the tetrahedrals. I thought these were so cool. I think that that'd be fun to do. Aim High, we had a 7 diameter squishy. 2007, Rack and Roll. We had inner tubes, Overdrive, and Lunacy. Lunacy was my team's first year. That was their rookie year. I was not the coach yet. That was a crazy year. We're going to talk about that a little bit later. Those things were weird. So Breakaway, 2010. This was when I first started coaching, 2010. 2011, inflatables, squishies, frisbees. That was awesome. Giant inflatable. There's the year Recycle Rush. That, yeah. So yeah. Okay. Can't say it. Yeah. All right. It was an interesting year. 2016 was a pivotal year, I would argue. 2016 was a dramatic shift, a dramatic change away from a lot of the things First had been doing. This was when we had themes come in and we were blown away. Everybody was just kind of like jaw dropped when they released the challenge for the theme. 2017, one of my favorite years. I love steampunk. This was a great, everybody loves 2017. 18, Power Up. 19, Deep Space. And of course, Infinite Recharge. Arguably this year is Infinite Recharge. And all of this to say, the first question you have to answer is, what the heck do you have to manipulate? And these are very dramatically different. So here's the question. Which specific game piece had the most appearances? Please type your answer in the chat. And you can't, as it says, as you see, you cannot just write the spherical one. That's ridiculous. So I want to see what you got. Tell me which game piece you think is the most. And this is the part. So some of these 8-inch ball. Okay, good, good. I'm not going to reveal the answer until the next slide, but I want to see some more answers here. Now, for those of you who've been around, some of you, the coaches who've seen this presentation, this is the part where I would throw candy very badly at the audience. And I tried to figure out a way to send candy through Zoom, not a thing apparently. So we got. So okay. You may be surprised. Okay, here's like a follow-up question. How many times do you think one game piece appeared? This is kind of crazy. I didn't really expect this. So we have reoccurring game piece, the 13-inch diameter and the 24-inch diameter exercise ball. Both of them appeared 5 times. Now the 13-inch diameter, this is like 2019 was the last time we saw this. It was for the hatch game for Deep Space. This was the orange ones that we had. What were they? I can't even remember, but it was. Somebody help me out with this one. So what did you have to put the hatch in? I always forget the names of the game pieces. I just call it the giant orange ball that we had to fit in there. So that was 5 times. Here's another one that might surprise you. These tied for 5, but 4 times. The squishy ball that we had last year, the 10-inch squishy ball, that had appeared in 2016 as a boulder, in 2012 before. And in 2016, 2006, Aim High, we had a situation where it was That was the first one, but it was 7 inches. Still, my point with all this is when the game piece reappears, you have to look back at previous games to figure out when it appeared and how people handled it then. Soccer ball actually showed up 3 times, as well as the inner tubes. Now there's a couple more that technically, so this one, the 30-inch diameter exercise ball was twice, and also the totes showed up twice. Here's another thought. If you think of the 30-inch and the 24-inch as roughly the same size, that's a whopping 7 appearances. They love to throw that at us, especially like last time I saw the 24-inch diameter ball was aerial assist, and the robot could only be like 26 or something crazy like that. Like it was like the robot was barely bigger than the game piece. All right, so some outliers. Tennis ball. I wish they would bring that back. That was cool. The floppies. Okay, these were like giant inner tubes, like the size of a floaty inner tube, but like if one of those floaties and a giant beanbag had a baby, that's what a floppy was. It was like filled with sand, and it was just a wreck to try to pick up with your robot. Probably why we haven't seen it. The tetrahedral from 2005. These things were like, they were insanely heavy, and you had to get them really high. So not surprisingly, a lot of robots flipped over that year. This was like the moon ball from Lunacy. That thing was just a nightmare to try to pick up for some robots. I mean, it's just a situation where it got weird because it was all like springy. Aerial assist frisbees. Frisbees were fun, but it was very different than anything we'd ever done. Steamworks, both the gear and the fuel were new. Power Up, the cube, that was interesting, very different. And Deep Space, the hatch was new. Now, when I gave this talk last year, we didn't know what the game piece was going to be for infinite recharge. And a lot of people very logically thought there's a pattern here, you know, outlier in 2017, outlier in 2018, outlier in 2019. But I've given up trying to find the pattern in game design, because as soon as there's something close to a pattern, then all bets are off. So great. You now know the game piece, but how do you have to manipulate it? This is the second question that's tied. You got to figure out what you need to manipulate. What is the game piece? How's this going to work? And we'll talk about research and things like that a little bit later. Second question is, what do you need to do with this thing? So most games have a relatively straightforward progression for the game piece. You bring it into the robot, move it around the robot, maybe. Sometimes you don't have to. And then obviously score the game piece. This is what you always have to be looking for, watching for, thinking about. So the thing with this is, what specifically do you need to do? Also, there's another part we're going to talk about, how many game pieces are available. That's another big thing you have to consider. Do you need to lift it? Do you need to dump, hang, kick, gather, throw, fling? Fling was not very common, but still, it was a fun year to do that. And a lot of these you can see, like some of these years you could have as many game pieces as you could fit into your robot. Some of these years you could only have one at a time. And that dramatically changes the manipulator you choose to manipulate the game piece. So these are some of the reoccurring tasks. Accumulators and collectors, that's if you have a lot of game pieces. Grippers, like you see in the images below. Lifting, long reach, delivery system, launchers. We'll talk about all of these things here. So the question is this: for an intake, what type of manipulator is good for the game? Well, it depends on how many game pieces are available. If there's a lot of game pieces and you can handle, you can hold like 10 or 20 at once, then you're going to be looking for collectors, accumulators, and conveyors. If there's only one game piece, then you're going to want a gripper, roller, clamp, or claw. Now, that being said, some teams are like, you know what? Even if you can only hold one game piece at a time, there are teams that still go with like a collector accumulator, just because it tends to be able to gather from a larger array and you don't have to focus in. If your driver's not so good at the fine tuning, then you want a bigger capture system. Here's the other thing though. Regardless of what you decide, what type of manipulator you want, the question is always control. You want to avoid gravity feed if you can. Murphy's Law. with robotics. If anything can fail, it will fail, and it will fail spectacularly. Probably after you've made it into the elimination round. I just don't, gravity feed can jam, and it's slow and it's unpredictable. That's really the problem. It's unpredictable. There's a couple of solutions I'll show later on for mechanisms that are pretty elegant for how to solve that problem. You need to be able to direct the flow. This is something else teams don't always consider. Pieces can look brutal by the end. By the time you get to eliminations, those game pieces can often be shredded and have seen a lot of wear and tear on them. All right, so accumulators. The one in the lower right, so accumulators, there's horizontal ones like this. This is good if you have a large, like one of the exercise balls, then, you know, accumulator from the side like this one, horizontal rollers, that's great. This one is probably for Recycle Rush 2015, where you had to pull it in. But a lot of teams use that same concept and design when we had Power Up, because pulling in a tote is very similar to pulling in a yellow cube. So that worked really well. If you're talking about trying to control spheres, balls, game pieces that are squishy, anything like that, then a vertical roller is extremely helpful. This sucker you just put down and it goes over the top and just pulls the ball in. It's very, very nice. Wheels, nice for the bigger objects. You can also, the other beautiful thing about this is you just reverse the motors to kick the thing out. It's nice and easy. Your intake is your scoring mechanism. It's very simple. You want to try to keep it as simple as possible when you have a lot of game pieces. Now, a different one, getting a grip. Okay. If you're going to have a gripper, a grabber, a holder, something like that, you have to think about the surfaces of the object, high friction surfaces. You got to also think about corners. If you're talking about any sort of thing that has air in it, which a lot of the game pieces have had air, they're inflatable in some way. So you got to be careful not to puncture. This is something else teams don't necessarily contemplate. The force at the highest grip point, the force should equal about 2 to 4 times the weight of the object, because we often consider, like if you have like some sort of an arm grabber thing, where you grab the game piece and then you've powered the motor that actuates your lifter arm on your mechanism. But teams don't often necessarily realize that, like, you need to have a lot of force holding that thing in there. So it's just something to be aware of. Something else that people don't often consider, because, you know, we use motors, we want to have control, but it's almost always a great idea to add in some sort of mechanical advantage. This is no matter what you're using for your manipulator. Springs, bungees, levers, anything like that at all to assist your motor so you don't blow your motors out. Also, it helps with your electrical audit that you're not using as much electricity. The other thing to consider when you're building a grabber is this. Quickness covers mistakes. You're going to probably drop the game piece. It's going to be hard. You want to try to build a grabber that doesn't rely on precision and accuracy as much as you can. So be able to like quickly reposition, regrab it, because that will happen and you need to like plan for that. All right, so how do you grip? There's pneumatic claws, clamps. That is always an option. That's a pretty good one. Motorized claws or clamps. Rollers are pretty common. Suction is doable, but problematic. But we're going to talk about those real quick. Pneumatic claws. These are fairly straightforward, especially if your team is good at pneumatics and you have a lot of experience with that. Can be powerful, give you a lot of control. That's the thing that's beautiful about it, can give you a lot of control. Here you have a combination, which is almost always a good idea. They have wheels and a clamp and a piston clamp there. So it's good to include this. This is Dr. Claw, motorized clamp. This is from team 2471. Now the ironic thing about this team is one of the mentors on the team, Bruce Whitfield, who I borrowed a lot of, or some of this information from, once said you should never have a motorized clamp. And then the team that he mentors built a motorized clamp. And this reminds me just to be like, never say never. I'm not a fan of certain things. I love other things, but yet I think our robot 1 year had, there are 3 things that I don't enjoy having on a robot. We had all 3 on the robot that year, and it was just a little bit of the kids kept ribbing me for that one. But motorized clamps, they can be slower and less powerful. The question is, what do you need it for, and how often do you need it? This one was a situation where they were using their pneumatics to launch the Game Piece. So they wanted to have all their power available for that. So they went with a motorized clamp to allow for the piston to be the kicker. And it's always a thing where you have to consider what's going on. All right, so suction, pros and cons. It can be simple. The problem with, it can be simple, but or it can be used to hold, but it's simple in as much that you just have a sucker and then grabs it, yay. The biggest problem with, you can like, look at this. So pros, I got 2 dots. Cons, here we go, here's the list. You need a vacuum generator. This requires precision placement. It has to be perfectly placed on there. There's no force control, it's on or off, but the biggest reason why most teams stay away from suction grip is because the objects become damaged. Once the game piece has been scuffed up and scratched, then it's really hard to get a decent vacuum seal. Also, game pieces are heavy. You need a really powerful vacuum. Now, all that being said, teams have used it successfully to, especially if you don't necessarily have to pick up the game piece, if you're just kind of like herding it around, that has been useful. This thing looks impressive though. That just looks cool. That, I don't know what you call it. That reminds me of the lamp from Pixar, and I feel like that's what you should call the robot. So you can tell I'm not a huge fan of suction. There's 2 slides with the cons from suction grip. It's just, yeah, hopefully you get the idea here. So roller grip. Roller grip is extremely popular because there's a lot of different variations here. These 2 are very similar designs, and the beauty of it is like a mixed roller conveyor. That's sweet. You can reverse the top and the bottom roller directions to rotate the object. This one, so what I'm trying to say here is that like the best use I saw was 2012 Locomotion. They would pick up the game piece, which was an inner tube, and they'd be able to rotate by spinning the motors different directions. This was extremely useful to be able to move it around. And there, we haven't seen a game like that, but who knows what's coming in the future. So that is kind of beautiful to be able to do that. So conveyors and accumulators. Now, conveyors, conveyor belts. We had on our 2020 robot for the game pieces, the power cells, we have a conveyor built onto our robot for that. A lot of popularities here. You have neoprene, basically like the tubing that we use for the pneumatics. People will often use that. The question you just have to be asking yourself a lot is about grip and friction. Now, the other thing is this. There's a lot of moving objects, and when you're trying to move a lot of objects, you have to realize that you're going to have some jam issues. So you have to figure out what's going on here. And there's a couple of different ways to do this. You can, in this situation, you low friction material on one side, and it's complicated, as is always the situation with all of these decisions. And the answer to what's best is always complicated, and it depends. So in this situation, you just have low friction on one side with the belt. That'll help. Individual rollers can help over a belt situation. The problem is that adds a lot of weight and often complexity. You can do 2 belts, which should be showing up. There we go. 2 belts. It is more complicated. However, it can be a heck of a lot more reliable. And that's, I don't know. Maybe that's not your team. My team, we try to focus on reliability. We don't always get there, but that is the goal. Now, some examples of conveyor belts. This is a belt system from 2012, Rebound Rumble. That's almost identical to the one that we built with those belts. This one looks cool. That one just looks beautiful with its spiral tower thing. Yeah, I actually think that's kind of cool. And it is honestly quite simple when you think about it. There's a pillar in the center that rotates, and that's what brings the balls up to the shooter. This thing, I don't know if those are like pool noodles or what the heck those are. But this thing is pretty impressive as far as conveyor belts go. Now, in these situations, this was taking it up to a shooter. This one's taking it up to a shooter. This one is taking it up to a dumper. So those are, pretty similar concepts. They pull in from the bottom and they lift it up to the top of the robot. So how do you power a conveyor belt? As always, there are options and it depends. Now, the thing you have to contemplate is this. If you're going to run it off of 2 motors, well, okay, good. Just make sure that your programmer knows how to do that really well. The other thing is sometimes it's nice to have them on 2 separate motors so that you can spin the devices inside. Most of the time, though, when you're talking about a conveyor belt, you're just pulling a bunch of them in, so you don't really want that or need that. So you want to have both sides of your conveyor operating in tandem. Well, okay, you got to think about that. There's a couple of options. You can cross with a round belt, cross one of the belts. These are crazy dangerous. I don't know. I'm not a fan of crossing the belts. Maybe that's just because I really liked Ghostbusters when I was a kid. But for us, we're going to be doing, my team, we're going to be doing belt on gears or gear situation. So that in this one, you power one of those gears. You just make sure that you have a gear in the middle so that the rotation gives you the correct rotation. All right, scorers. Sweet. Now, we got shooters, kickers, buckets, and tables. This one is the team out of Alexandria. My brain kept trying to say Andrea, didn't work. It's weird. So the team out of Alexandria, Mechatronic, they built this and they called it Thor's Hammer, and it was glorious and brilliant and wonderful for its simplicity. We'll be talking about that design in just a bit here. First up is shooters. So shooters, okay, this is, all right, lots of things here. If your team has never built a shooter because you've not had to based on the games, it is a really good mechanism to have some experience with. Try some things out, figure some stuff out. So more control is always better. Avoid gravity feed, as previously mentioned. Try to reduce the random movement. And then this is what we've kind of been talking about a lot. They become misshapen over time. Another one, speed versus volume. This is one where you really have to consider the game and your strategy. All of your designs, all of your manipulators, they should all really fit into your strategy for the game. If you're only allowed to hold 3 game pieces, then you're going to want to have a situation where you can be fast. And if you can have 10 game pieces, well, then you're going to want to make sure that you have an accumulator, you get a perfect lineup, and then your shooter just goes to town and brrr, right out of the bat there. So single wheel, this is a single wheel mechanism versus a double wheel versus a catapult. Okay, so first, shooters, so single wheel, the problem with this is you have to have a low friction surface on the other side, and that's usually not necessarily a problem. It's just if one of the game pieces has more friction, it creates a problem. Single shooter, you're going to get backspin, which maybe you want that. That can be really, really nice in certain game pieces if there's a backboard or something like that. That can be beautiful. Double wheel, we're going to talk about that a little bit more later. Double wheel, it's just a lot more control. You're going to get a lot more accuracy, assuming that you're able to get the motors, like in this situation. These motors, there's a motor on each of the wheel systems. That can be problematic because if they're not turning at the exact same RPMs, if they don't start up at the exact same time, you're going to have some issues and the ball could go off in directions you don't want. Most teams solve this by having, if they have a 2-wheel system, they'll connect it by a chain or a belt. So here we go. Shooters. Generally, always, a secure shooting structure will be more accurate. Now, this one has, I believe, this one has a turret at the top. We'll talk about turrets a little bit later and the pros and cons of that. Regardless, you want to be able to control the flow of the game pieces and the feed to your shooter. Rotating tubes is very common, wheels. You're going to want high speed, high power. I know that's like those are like opposite ends, but you want to try to make sure you can get that. Speed is really critical here. Another thing that, like, if you don't have some sort of a sensor to detect the presence of the ball, that is really critical or crucial. Trying to rely on the driver's eye to make sure they have one, it's probably not the best. I mean, if nothing else, just have a camera pointed at your mechanism, and you should have a separate mechanism to actually push the game piece into your shooter. That is best. Now that can become problematic. So a lot of teams, they'll have like a conveyor belt that brings the balls up. You're going to want to have a separate mechanism to actually put the ball into the shooter. Now I know that's added complexity and that is hard, but at the same time, relying on your conveyor, it can cause issues. So why should you use a turret? This one in the, why not move your robot? So this was a year, this was 2016 Stronghold. I can't give you candy for the answer. Sorry, I thought I got rid of that one. But why was it a good idea to have a turret in 2016? Anybody throw an answer out in the chat, and then we'll see. We'll go from there. I'm looking at the chat. I don't see. All right. Well, in general, for games, you have a situation. The turret is really good if don't need the robot to directly face the tower. Good. Thank you very much. The problem with that year, there was a lot of defense, and defense is always an issue, or can always be an issue in the games. And if your robot, if you don't have a turret and you choose to rotate the bot, you know, that makes perfect sense, especially if you have a very versatile robot that can turn on a dime, which, you know, 6-wheel tank drive, a lot of us can. The problem is that means that you can only shoot from one spot. And if a defender gets in your way, you're toast if you can't shoot from that spot. So it just becomes problematic, especially if there's only one goal for the game. Also, for those of you who are from the Central Minnesota Robotics Hub, you know the lore of Becker Robotics team, CSI 4607. Their first year, they put a t-shirt on their robot, and it was an amazing defensive robot. And then another team in the hub did that their rookie year. So it's kind of like a rite of passage that the rookies in our hub at some point throw a t-shirt on their bot. So defense and time. It's harder to block a bot that has a turret. It's very, very difficult. It can often be faster and more precise to move the shooter than to move the bot. Now, that, yeah, because I mean, think about this. Unless you have, if you have Mechanism, okay, cool. Then you can very easily move your robot. But a lot of times it can be easier and more precise to move the turret. And this is especially true if you have a situation where you can shoot multiple times from one spot. You can hone in much more easily than trying to move your entire robot. So when is it a good time to use a turret? When there's one goal, fixed target. If there's multiple goals or moving targets, and I know that sounds crazy, moving targets do exist. There were times where you had to follow your enemy around and score into a trailer they were towing behind them. So that's the situations where you would want to have a turret. So if you're going to build a turret, rotating turret, then what you're going to want to do is make sure that you have, there's got to be some sort of a bearing structure. It's got to be heavy duty and solid. This thing has got to have a lot of forces on it. You're going to need to rotate a large amount of weight, and you need sensors because good night, this thing, yeah, it's problematic without them. If you can do auto aiming, please do. It is the best thing you can do for your robot and your driver. So vision tracking system would be glorious because, and it's often easier, at least I've been told by my programmers, it's easier to have a vision tracking system that is running a turret than it is to have a vision tracking system running your drivetrain. Now, I don't know, I'm trusting them on this one. So this is what I mentioned before about loading mechanisms. The problem with loading mechanisms is most of us, a piston is what we know. And yeah, that's great and that's good. My, I don't know, hesitation with pistons is that, like, if you already have pistons on your robot, you know, sweet, great, throw a piston on there, yay, happy day. But if you don't have pistons on your robot, then it seems it's hard to justify adding the compressor and the canister, adding everything on just for one mechanism. but you know, some teams like, we're doing it. Okay, cool. There are alternatives for motor ones. These are just, I think they're elegant. I think they're beautiful. The Geneva gear or the reciprocating gear, these are things that allow you to have a motor that will push a game piece in one at a time. And you don't have to worry too much about the precision of the situation. All right, so buckets and tables. Green Machine is in this one. This one's from 2009. This was forever ago for a lot of us. Buckets and tables are really good if you're dumping a whole lot of objects, and it's pretty easy to integrate with your collector. We saw this a lot with people who, for this, when we had Steamworks, there were a lot of teams that would have their collector and their bucket, their dumper was the same thing. They would get fuel, and then they just go and dump it into the other one. If you don't know this team, this is 254, the Cheesy Poofs. Bit of a silly name, great robots. So heavy buckets can be slow. That's often why people choose to go with pneumatics to power this thing. I would recommend if you're gonna have a big bucket dumper, it's gonna be heavy. Springs are a really good idea to have this. Always a good idea to add in a little mechanical advantage to help your motors, try to make sure those things don't burn up. So that is the end of that. So in summary, what I want you, and I want to make sure we finish up for, I know I'm guessing they want to get back on track. I also wanted to save a lot of time for questions. Questions are usually a very, very common part of this. So what I want you to understand here is this. Look around, see what works, and more specifically what doesn't. The reason why I spent so much time in the beginning showing you guys all those game pieces from past years is because last year, when a 10-inch squishy showed up, first thing my team did was went back and look at designs from 2016 and 2012 and saw how teams used that, how teams were able to pull it in, what was the best thing that they did. We even emailed some people and said, we saw your picture online, that conveyor belt was amazing. What the heck was the material that you used for that? And how much did it cost and where'd you get it? And that can save you an insanely large amount of time and energy. And in this case, don't reinvent the wheel. The other thing that teams often, make sure that you know your design objective and your game strategy. When the game's released, my team, we always start talking about like, what's our strategy? What's our strategy? And inevitably the kids or me or somebody will be like, we should build a winch system for the end. I'm like, okay, great. Sweet. That's a great idea. We're going to talk about that later. Right now, we need to focus on what is our strategy, because that should guide all of your design decisions and help you figure out what your mechanism is. Like, look, if you're a defense bot, if you know you can't build a precision shooter with targeting from, you know, a sensor and a camera, if you know that's not in your wheelhouse because you're a young team and you just don't have that ability, then it doesn't necessarily make the most sense for you to build this glorious, wonderful conveyor belt system that goes up to a shooter that doesn't really work. It's just something you need to know where your capability is. Hey, look at that. So you need to stay within your capabilities. Like, know your limitations. That's not a bad thing. It's just you're not there yet. Also, the other thing that people don't necessarily think about, and this is more true in session 2 where we talk about like larger manipulation things, calculate the forces and the needs. How much does the object weigh, the game piece? How heavy is it? How much energy are you going to use up? We often have these beautiful designs that are just not strong enough. And then our rule of thumb is we calculate the amount of force needed, we calculate the object's need, and then we double it. We always double it. Because what I'll talk about in the third one is every time you do a gear reduction, you're losing minimum 10% of your energy. Understand the dimensions using CAD. We've finally got some kids that are trained up and skilled enough in CAD that we can design in CAD before we start building. That's always been a goal for us. We haven't necessarily always managed to do that though. Keep it simple, make it well. Poor craftsmanship can ruin the best design. We had a team one year came over and they had a very, very similar design to ours. And the mentor is like, I love your design. It's beautiful. And I'm like, yeah, it doesn't work. And he's like, yeah, I know, you didn't build it well, but it's a beautiful idea. And I was like, thank you, I think maybe. But he was right. We'd left it till the end. We didn't put enough time into it. And it was a great idea that we did not execute well. And so you have to like think about that. Also, refine the design, decide on spare parts. And then this, if you take nothing else away from this presentation, have fun. Put some googly eyes on it. That's become a requirement now for our robot. There's got to be googly eyes somewhere on the robot. And this is also another thing. Name the manipulator. It's really hard because like you're like, people always talk about like the grabber thingy or the game the thing. Call it TED or something like that, or come up with a cool acronym, or like the hand of God or Thor or whatever you want. Anything like that, you're going to want to have a situation where you name it something like that. So I want other things credits. This PowerPoint was modified from one that was created by Bruce Whitfield. Bruce, it appears when I was doing research to create this PowerPoint, I found a PowerPoint by Bruce, and then I found an older PowerPoint from Andy Baker. And then as I researched, I found even more going back into Greg Needle. And for all I know, these slides go all the way back to Dean Kamen. If you're with us next time for part 2, there's a specific slide, and I'll point it out, that image was used in all the PowerPoints going all the way back. All right, so any questions, please type them into the chat. And this presentation will be available on the JUMPSTART website. So go ahead, type all your questions that you want. And I got a 3-minute warning. But I'll be happy to answer anything that you have, or any questions that you have. Also, that Geneva gear, we haven't built it yet, but man, I've pushed for it like 3 times. So the kids get to make the final decision. What's your favorite game piece of all time? Excellent question. Well, okay, I'm partial to, it's got to be the gears. Just because I love Steamworks, Steampunk, that was an amazing year. I loved that. My favorite part about the gears, though, was because they were so intricate in the game design. Like you had to get the gear up to the airship, and then the gears had to be used to make the propeller spin. That was glorious and beautiful. I loved how it was. Most game pieces are like, you take the thing, you throw it through the goal, and yay, you made a goal. But also it's a gear. I mean, is there anything more symbolic of robotics than a gear? I love that thing. It's one of my favorite ones. Not the easiest thing to deal with, though, to be honest. It was complicated to manipulate in some cases. A lot of teams, there were gears laying on the ground a lot. Any other questions?
That was a really great presentation, Mark.
Thank you. If there was anything that you didn't see and hear, like I know I mentioned the kicker, and I'm like, we'll get to that later. That's probably good. I believe I moved that to part 2 of the presentation. So if you're looking for that, that is a nice design. And I put that into the part 2 slide. So sorry if I got your hopes up for that one.
Keeping them on the hook for next time.
Yeah, that one's just brilliant with the counterweight. I love the simplicity of it. Yeah. But yeah, this PowerPoint will be up there. My information is here. This PowerPoint is already available on our team's website. This is my email address, isd728.org.